Now we discuss Newton's third law of motion. That is, to every action force has equal and opposite reaction force which acts simultaneously. Force and effect of force seen by Newton's first and second law of motion. In nature, force cannot seen. Similarly, force cannot act alone. Action and reaction are terms express force. These forces act in pairs. Action and reaction forces act simultaneously. Action and reaction forces act on different objects. They do not act on same object. Hence, cannot cancel each other. This idea is expressed by Newton in his third law. For example, gun recoils when bullet is fired. Now we discuss law of conservation of momentum. Suppose an object A has mass m1 and its initial velocity is u1. An object B has mass m2 and initial velocity u2. Initial momentum of A is m1 u1 and that of the B is m2 u2. Suppose these two objects collides, then F1 be the force acts by A on B and its velocity is v1. So its momentum is m1 v1. According to Newton's third law of motion, body B also exert equal and opposite force on B, that is F2. Its velocity is v2 and momentum is m2 v2. According to Newton's third law of motion, that is F2 is equal to minus F1. Negative sign indicates force acts opposite, but F is equal to ma. Therefore, F2 is equal to m2 into a2 and F1 is equal to m1a1. Substitute in above, then we get m2a2 is equal to minus m1a1, but a is equal to v minus u divided by t. Substitute this in above, we get m2 into in bracket v2 minus u2 divided by t is equal to minus m1 in bracket v1 minus u1 divided by t, that is m2 in bracket v2 minus u2 is equal to minus m1 in bracket v1 minus u1, that is m2 v2 minus m2 u2 is equal to minus m1 v1 plus m1 u1, that is m2 v2 plus m1 v1 is equal to m1 u1 plus m2 u2, that is total final momentum is equal to total initial momentum. Thus, when no external force acts on two interacting objects, their total momentum remains a constant, is known as corollary of Newton's third law of motion. Similarly, it can also be explained as when two objects collides, the total momentum before collision is equal to total momentum after collision. In this way, we all of us discuss first chapter. You solve exercise in your notebook. Okay.